Dawn. The daily cycle of the sun begins on Earth's eastern horizon. Each day, the sun's light penetrates the darkness as it has for eons. But during this limitless span of time, man has evolved from the primordial state to the sophisticated technology of spaceflight. And at Cape Canaveral Air Force Station, Florida, the United States Air Force has established an unusual museum, one which has permanently preserved with actual space hardware a history of rocketry leading to man's venture into space. Through the past decades, a trailway to the stars has been blazed by hundreds of major launches from Cape Canaveral. These were the great moments in space history. And at the Air Force Space Museum, the memories of these milestone events are preserved for posterity. The museum grounds, which include the launch sites for America's first satellite and first astronaut, are home for a unique display of missiles and rockets, some rare and forgotten. The flesh and blood human experiences leading to space. That story begins with the primitive skyrockets used by the ancient Chinese over 2,000 years ago. These arrows of fire were used to chase away demons and to please the gods. The first significant use of military rockets took place at the siege of Fort McHenry in 1812. British rockets hurled explosive warheads to targets 1.5 miles away, an event which inspired the phrase, "the rocket's red glare," in our national anthem. During World War I, rockets mounted on French pursuit planes were effectively used to destroy enemy observation balloons. One of the key developments in space history began with Dr. Robert H. Goddard, a physics professor often referred to as the father of modern rocketry. In 1926, at Auburn, Massachusetts, he created and fired the world's first liquid-fueled rocket. It rose to an altitude of 184 feet in 2.5 seconds. Eventually, Dr. Goddard's propulsion system would take men and machines to the very surface of the moon. During World War II, German scientists developed a potent weapon, the liquid-fueled V-2 rocket. V-2s, armed with high explosive warheads, rained heavy destruction on Great Britain. After the war, V-2 rockets and German scientists arrived at White Sands, New Mexico, where an American program of research and development was started. As the program expanded, a larger and better situated launch area and range was needed. The choice was Cape Canaveral, a narrow strip of Florida marshland facing a 5,000-mile stretch of uninterrupted Atlantic Ocean. On July 24th, 1950, Bumper, a modified V-2, became the first rocket to be fired from the Cape. With this successful launch, a new era in rocketry began.
Looking backward, 1954 doesn't seem so very long ago. It was in that year that we launched the Nautilus, our first nuclear-powered submarine. But the energy potentials of rocket engines and motors were only hopeful, tentative figures on bits of paper. Turning those bits of paper into reality was the task initially assigned to General Bernard A. Schriever.
In 1954, rockets meant different things to different people. To some, rockets meant missiles, a great added deterrent strength for our national security. To others, rockets meant the power for extending that security farther into space, for military and scientific research to the moon and beyond. All turned out to be correct, because today, rockets represent the power to accomplish whatever missions we require. How we got that power is a story worth telling. The fact that it is a success story is due to many people in many areas of effort, and to the foresight of our scientific advisory boards, of the industry, of our Department of Defense, and the Congress.
In 1954, we had small rockets, but our missiles and our rocket power were still mostly on paper. Reduced to basics, what we needed were 4 items. Item 1, the airframe. Light but strong enough to carry the fuel and oxidizer for the engines, which were item 2. Rocket engines of sufficient power. Item 3 was the re-entry vehicle that must travel through space and re-enter the Earth's atmosphere without being burned to a cinder by friction. Item 4 was guidance, to provide accuracy on a 6,000-mile journey. Of the 4 items, we had only a start and the knowledge that technically we could have them. The question was, how soon could we have them? It had normally taken about 12 years to develop new weapon systems. Now it would have to be done in something like half that time. And then within 2 years, our first ICBM, Atlas, was in production. The rocket engine program had been stepped up to a point where instead of 1 supplier and 2 or 3 test stands, a number of suppliers and many test stands were active. Other companies and laboratories were working on the complex problems connected with guidance. Other companies still were on the road to solving the problems of the searing heat of re-entry. In addition, the Air Force had the services of a civilian organization staffed by top scientists as systems engineer and technical director. But results after only 2 years went far beyond 1 ICBM program making positive progress. Now, several programs were driving forward to meet the relentless challenge of our time. An intermediate-range missile, Thor, was also in production. By taking advantage of engines and guidance systems already in advanced development, the shorter-range Thor could be made operational before our long-range missiles. The planners and managers of our national security had also decided to develop a second ICBM, Titan. Titan would have a more rugged construction and also would have growth potential in terms of range and future use as a space booster. Titan would be our first missile to stand on guard in underground silos hardened against nuclear attack. And long before we had the power to reach out into space, a spacecraft was already in active development. A spacecraft designed with the built-in versatility to perform a variety of missions. And also, even before we had our large liquid fuel engines off the ground, tests were being made for development of large solid fuel engines. These are historic scenes. But in 1956, only a few people recognized what these tiny test vehicles would mean to all of us today.
Missile test programs with strange-sounding names soon crowded Cape Canaveral's launch schedule. Matador, an Air Force winged missile launched from a mobile platform. It flew at subsonic speed and had limited range. Snark, the first missile designed to have intercontinental range. Redstone, a U.S. Army short-range ballistic missile. Redstones would eventually boost America's first satellite and first astronaut into space. As testing increased, a national commitment to future rocket programs was demonstrated by the construction of new facilities. a center for control of range safety, instrumentation, and scheduling, larger launch pads, and advanced electronics to record the rocket's flight for later analysis. This was Navajo, a winged jet rocket-boosted system designed for a 5,000-mile range at supersonic speed. Despite the resemblance to today's successful space shuttle, Navajo was plagued with difficulties. It did, however, provide answers to many technical questions about propulsion and guidance. As testing progressed, much was learned even from its dismal failures. Knowledge gained from Navajo was a factor in the success of Jupiter, a U.S. Army intermediate-range ballistic missile. Jupiter helped solve the problem of nose cone re-entry into the atmosphere from space. The Air Force Thor, another intermediate-range ballistic missile, a rocket which performed so consistently that it continues to be used by NASA as the standard booster for many of its satellite launches. But even as we made progress in rocketry, so did the Soviet Union. In October 1957, the Soviets captured world attention with the launch of Sputnik 1, a 184-pound satellite which circled the Earth every 96 minutes. Spurred by this achievement, the U.S. Navy hurriedly attempted to launch a Vanguard satellite from the Cape in December 1957. It failed after only 2 seconds of thrust. Reaction to this failure was swift. An earlier rejected plan by the Army's General George Medeiros and Dr. Werner von Braun was quickly put into motion. A modified Redstone called Jupiter C was prepared for the launch of America's first space satellite from Pad 26, now the site of the Air Force Space Museum. On this historic occasion, a dedicated launch team headed by Dr. Kurt Davis completed the countdown. On January 31st, 1958, the tiny 31-pound Explorer 1 satellite rose into the night sky. 98 minutes later, orbit was confirmed, and the first step of American space exploration was accomplished.
This is the lighthouse at Cape Canaveral. Built in 1867, it has been guiding ships safely past the Cape for nearly 100 years, long before missiles began to grace the scene. The view from the top is beautiful. From its 165-foot high vantage point, one can see for miles in every direction. Here, a sergeant with some spare time on his hands has decided to drink in the panoramic view from the top.
Okay, that's it. Wrap it up.
That was a fine shot, but then I guess you've had plenty of experience.
No, that was my first shot. I'm really a lighthouse keeper, but I like to think for myself.